Here we have two hand carts, like what might be on railroad tracks, where you pump the handle and that causes the hand cart to move. Hand carts A and B are on a train track. A, with passenger, has a mass of 185 kilograms and moves at 3.5 meters per second to the right. B, with passenger, has a mass of 150 kilograms and moves at 2 meters per second to the right. B starts out 15 meters ahead of A. How long before A catches B? There's 15 meters between them, and cart A is moving 3.5 meters per second. Cart B is moving 2 meters per second, so there is a 1.5 meter per second closing speed, or relative speed. How long will it take at a rate of 1.5 meters per second to make up 15 meters? 10 seconds. How far do A and B go in this time? A is traveling 3.5 meters per second, so in 10 seconds it will go 35 meters. And B is traveling at 2 meters per second, so in 10 seconds it will travel 20 meters. And that difference is the 15 meters we were just talking about. 35 meters and 20 meters, the difference is 15. At this point, A collided with B. What percent of the initial kinetic energy is lost if the hand carts couple? In other words, after they bump into each other, if they stick, then what percentage of the initial kinetic energy is lost or not easily recovered as heat? To do that, we need to know the final velocity of the coupled hand carts. This is a perfectly inelastic collision. We're going to solve this problem by conserving momentum. We have our mass and our velocity for each of the carts initially. If the carts couple together, then they will be moving as one object, and their total mass will be the sum of carts A and B. So 185 plus 150 is 335 kilograms, and those carts will be moving at a common speed if they're stuck together. What's on the left is the initial momentum of the system, and what's on the right is the final. They're both moving to the right, so let's call to the right positive. The momentum of cart A is 185 times 3.5, mass times velocity. For cart B, it's 150 times 2, mass times velocity. And on the right, mass times velocity, 335 times VF. And according to the law of conservation of momentum, those two quantities should be equal. If we figure out what's on the left side of the equation and then divide by 335, we find that the final speed of the hand carts is 2.83 meters per second. Now, the question is, what percent of the initial kinetic energy is lost? So let's calculate the initial kinetic energy of the system. Kinetic energy is 1/2 times m times v squared. Initially, carts A and B are separate from each other, so we have to calculate the kinetic energy of cart A, 1/2 times 185 times 3.5 squared, and the kinetic energy of cart B, 1/2 times 150 times 2 squared, and add those up, 1433 joules. At the end, the carts are stuck together and they're moving as one unit. The mass is 335, and we just found, using conservation of momentum, that the new speed is 2.83 meters per second. So 1/2 times 335 times 2.83 squared, 1341. Sure enough, some amount of kinetic energy has been lost. The percent lost is the number of joules that are lost, and the number of joules lost is 92. That's the difference between what we started and ended with. 6.4% of the initial kinetic energy is lost. Final thoughts on conservation of 1D momentum 4. In this problem with carts A and B, we know right from the beginning that the final velocity of the coupled carts must be between 2.0 meters per second and 3.5 meters per second. Here's how. When cart A smacks into the back of B, A receives an impulse from B that acts to slow A down. When cart B gets rammed by A, B receives an equal impulse that acts to speed B up. Since the two carts stick together, they must end up with the same velocity at the end, namely a velocity between 2.0 meters per second and 3.5 meters per second.